Hello, everyone. Welcome to the first Azure Community Stand-Up for Azure Cache for Redis. My name is Catherine. I'm a Senior Product Manager in the team. And everyone, regardless which region, which time zone you are in, welcome. So here is the agenda for today. Firstly, we will have a recap on what is Azure Cache for Redis for those of you who are new and who are interested. And then we will have a quick update on what's new since last community call. We have shipped a bunch of awesome features to enhance your experience with our product. And finally, we will look at the two scenario highlights for better using Redis Cache to improve your application performance, and for using Redis Cache with your intelligent application. So, introduction to Azure Cache for Redis. Firstly, Redis is a very popular open source in-memory key value store that's often used for improving an application's performance. It's currently hosted as a first-party service in Azure and is the recommended caching solution. There are two streams of Redis product. One is the open source based, another is the Redis Enterprise. So we make both offers available in Azure, and both of these are joint first-party hosted. So what can I do with Redis? Well, there are a bunch of scenarios related to caching, streaming, web sessions that you can use Redis for. So for both OSS and enterprise SKUs, the common scenarios are distributed caching. Suppose if you have multiple web servers hosting your application and you need cache some data, you don't want to save the data in memory in the web server for resiliency and performance issues. So you want to put it in an external store such as Redis. And web page output caching. This is something new that we just released last November with .NET 8. Basically, you can cache the web content so the web server CPU doesn't have to run again to generate the content, the HTMLs. And this will help improving the consistency and the performance of your web content. Other common scenarios including the session store. You may want to persist what users were doing throughout the session, and you want to externalize it because in case connection lost, you don't want the user to start everything over again. Leaderboard, that's another super common scenario. For gaming, you want to display the rankings of the players real time. Same goes with sport matches, e-commerce website, like the top selling products and so on. And we have a bunch of more scenarios like message broker. We'll talk a little bit about it with the functions integration, geospatial data that's often used for gaming, like the 3D coordinates will be cached for faster rendering the graphics. Shopping cart, similar to web session, people may choose things and then later delete it. So no reason to persist everything directly into the database. Writing to cache is much faster. IoT scenarios, hundreds and thousands of devices may send to Redis cache for getting the data processed in real time. SignalR, Redis cache can be a good backend for SignalR, although Azure also has a managed offering, and you can go try it out. Now, with Enterprise Redis, you can install modules to even further enhance the capabilities. So we have the Redis search module that enables us to perform search, especially with the intelligent applications, vector similarity search, is a very popular scenario now. With the Redis.json module, you can use Redis, which is an in-memory store, also as the NoSQL database. Redis time series enables you to store the data in a time series format, so you can do real-time analysis and things on top of it. And then finally, ReadyBloom, that is for the statistic data format and common scenarios fraud detection. Like if you have a lot of user requests, say credit card transactions, how likely some transactions are fraud. Next, what's new? Since end of last year, we have shipped a bunch of improvements in the product with the client libraries and also Azure integrations. So in the service-wise, we shipped additional SKUs with the enterprise. So E5, E200, and E400. Those are more pivoted towards the lower end for enterprise, so you can start at a lower cost and do your dev test scenarios with vector similarity search, for example. It's available in the Azure portal now, so go try it out. The enterprise skills are now available in more regions, like Japan East, East Asia, and Brazil South. So that enables you to better serve your global customers by provisioning the cache in the same data center where the web application is located. We finally support TLS 1.3 now for both OSS SKUs and enterprise SKUs. And when I say OSS SKUs, it means the basic, standard, and premium SKUs that's available in Azure today. So that's enhance the security. And activity log support is now GA for in December for the enterprise SKUs. So these are the monitoring and auditing features, and you don't get it with self-hosting. It's one of the advantages for using our managed Azure Cache services. In terms of how your application can use Redis Cache, for .NET 8 last November, we shipped the Redis support for iOutput cache. This basically means you can use Redis as the backend store for saving the web content output. Like I said earlier, this will save a lot of resource and computation from the server CPU and improving your web application performance. A very popular .NET library is Stack Exchange.Redis. Now, we shipped a few new releases. So firstly, in the Azure.StackExchange.Redis extension, we now support the Microsoft Entra ID, which formerly was known as Azure Active Directory integration. This allows you to connect to a Redis cache instance in Azure without having to save any passwords or connection strings. That enhances the security for your application overall. In the Stack Exchange.Redis library, we also shipped a few fixes, such as the web app Linux connection lost issue, so making sure our managed Redis cache service will integrate better with other services in Azure. And if you happen to use these libraries, please make sure you update them to the latest version. That's very important to keep your application running and keep everything ready. Otherwise, you may run into issues here and there. And the Redis OM.NET libraries are a higher level library maintained by the Redis Inc. We just shipped the vector similarity search and the semantic caching interfaces. You can go check out using the URL here. We make sure Azure Cache for Redis integrates well with other Azure services. So the function integration for binding and trigger are all in preview, which means you can write directly into cache, and you can use Azure function. You can use Azure function to take Redis either as the event source or as the output for caching any result. Here are some links to check out, which include the sample code. And if you have any feedback on the preview, please send the feedback to the issues section in the GitHub link here. So some scenario highlights. The first one, the Azure Functions integration with Redis event binding. So this is the preview item we're just talking about. Basically, this means for Azure Function, we can take triggers on Redis-generated events, such as key space notification. And upon this event, you can customize your function to do whatever task, which commonly should be writing the data into some persistent data store. So the diagram here shows how your overall application might be looking like. You have a web app front, and it can write directly into cache. Notice the in-memory nature of Redis cache makes not read faster, but write to it is even faster. So this will help improving your web app performance by a lot. And as the Redis cache receives some new data, it can trigger an Azure function to run and asynchronously writing the data to one of the persistent backend. So that way, your web app can just function with the Redis cache, all right? It can write to it, read to it, and the function behind the scene will do all the work to make sure data is persisted and decoupling this process from Redis itself. So your application don't have to wait for the data to be written to both Redis and database before processing a new request. Again, the link is here, so go check it out. This link is our GitHub repository that includes all the preview bits, the setup instructions, and the sample code. The next scenario I wish to highlight is the Semantic Kernel with Redis memory store. Semantic Kernel is the Microsoft developed SDK for large language models like GPT. And we support multiple languages such as .NET, Python, and Java. And a quick background context. So vector embeddings are the numbers representation of unstructured data. For example, text blobs, pictures, sound, and so on. So when searching this type of data, because it's not structured, it will be hard to say like which ones are relevant to each other. That's why we translate this type of files into vector embeddings, and then we perform search to see which vectors are closer to each other, and using this to decide which picture files, which text blobs, for example, are carrying similar meanings. Redis can be used as the vector database and to perform vector similarity search. This is based on the Redis search module that's available with the Redis Enterprise. So in the sample application that we will be looking at, I'm using Redis Cache to save the external knowledge in the format of vectors and performing search on it. Now you may ask, there are a lot of vector database solutions out there. And in the end, this is not really a data structure problem. This is a search problem. It's about which one is more suitable for your application. So why choosing Redis? Well, because in a lot of applications, Redis is already used as the cache or backend for data streaming, leaderboard, and so on. So if you can just add a module to your current cache and then use it as the vector database, it will save you extra effort to provisioning a whole new different resource and learn how to use it. So the existing knowledge on Redis and the fact you don't have to get another resource to your application are the advantages for using Redis in your application solution. So in my case, I'm not only use Redis for the external knowledge store, but also to save the user's preferences. So let's take a look at the application. I'll do a quick .NET run here. It may take a little while for it to get all the external knowledge and start up. But here are the code for the application. So here you can see I'm just using the Stack Exchange.Redis client the same way that I'll use it with other scenarios, like web session, leaderboard. It's going to ask me a username and see if it can find any system message preference. The system message in a chat application is basically telling the chat agent how it should behave. So a module like GPT can offer different styles of talking. You can tell it to talk in a very serious tone, talk to a normal tone, or be in the Shakespeare style even. These are all what the system messages can help, and not limited to this. So basically in the code, I'm firstly asking the username and then see if I have cached any preference for the user. If yes, it will just proceed using that system message string. Otherwise, it will ask the user what's your preferred chat style. And if the user gives any response, we will append it to our default system message, which is basically telling GPT, you are an AI assistant, and what are the tasks you should do. And we make sure the information is saved to Redis next time using it. So let's see. Yeah, so now the app is running. It's asking me for a username. Let me just enter, let's see, Catherine. So it did not know my preference earlier. Now it's asking me what's your preferred chat style. I'll just say, talk to me in a poetic. Okay, now it answers it enters the question and answer part. So I'll just ask, who are you? Okay, I think it just took the system default message. I'll ask it again, like, who are you? Remember to answer in a poetic style. Okay, now you see this answer is a lot different than previous, and you see how it rhymes now. It's a real poem from the answer. Now, I might be interested in what happened behind the scenes, so let me use the Redis Insight tool to take a look. I want to make sure like my earlier preference was indeed cached. Give a minute for the tool to load. So here I'm already connected to my Redis instance. This is an Azure Cache for Redis Enterprise. I know I was using set as the data structure. So you'll see this is the message I just entered. And here's the content. So good. I think it remembers my preference, and the next time loading the application, it will just read this string and respond to me in the preferred style until this information expires, like after a few days, and I get to choose again. Now, GPT is a large language model. It knows a lot, but not the content that came in after it gets trained. In addition, if you have any private content within your enterprise, there's no way for GPT to know about it either. That's why we need to put the additional knowledge somewhere attaching to this whole application so GPT can look for the additional content in order to answer the questions. So in my application, I'm using Redis as a memory store, and you can see how Semantic Kernel already provide a plugin for Redis memory store. And just for simplicity, I'm downloading the content from a recent blog post on F#. And here are the code for using the text embedding model to translate each paragraph, basically summarizing each paragraph and translating it to vector embeddings so we can do the search later. And this is the blog post that I was downloading. So it teaches us some quick actions for like fixing F# issues. Let's just take this error as an example since it gets mentioned in the blog post. I'll ask how to fix my typing to fix F# error. This is the code. So you can see here are the content generated, and the example and the guidance here largely align with what's mentioned in the blog post. I think there's a code section here. So that's an example, like reading Redis for getting external content and use that to enhance your chat application. And just to mention, the chat application that I added Redis is all based on this blog post. It's great content, so go check it out. And here I also want to mention a little bit about the Redis OM.NET vector search and the semantic search capabilities. There's a great blog post from Redis on that already. So basically, Redis OM libraries provide abstractions for like getting the .NET object mapped to all the Redis search and queries. And here, what we are doing is we added what we call annotations on a property field for any object. So we can specify, for example, the image URL that can be vectorized. We can specify the properties such as the vector algorithm, the distance matrix, and so on. So in this case, it also saves you a lot of effort for manually writing the code to convert different text blobs into vectors. This will do it for you automatically. and it simplifies your code, increase the success rate. This also comes with the queries that you commonly need for vector similarity search. And another improvement is on the semantic caching. So this means in a chat application, when you interact with the bot, there might be questions that are essentially the same in terms of meaning, but asked in different ways. So sometimes we may want the chatbot to respond with the same answer, so that can save the query and load on your backend. So here is an example, like what is the capital of France? What really is the capital of France? Using the semantic caching layer interface, this will return the same answers. Okay. And that's all we have for today. If you have any feedback, you can send it to this alias azurecache@microsoft.com. Thank you.